Okay, let's start section 7.6. We're going to use the number e to write and graph exponential functions representing real-world solutions. We're actually not going to graph them. We're also going to solve equations and problems involving e or natural logarithms. Those are two vocabulary words. Okay, e is actually an irrational number. If you guys get out your calculator right now and just do e, or e to the first power, it'll spit out 2.18281828. You're going to want to think this repeats, but it does not. As it keeps on going, it doesn't repeat. So it's an irrational number that goes on forever, sort of like pi. A logarithm with a base e is called a natural logarithm and is abbreviated with the ln. Okay, we don't use log base e, we use ln, and we still call it log, but it's a natural logarithm. It has the same properties as log base 10. So all the properties we've been learning this whole chapter apply to natural logs. So the same properties as log base 10 and logarithms with other bases. So the natural logarithm function, f of x equals ln x, is the inverse of the natural exponential function. So we do a lot of, logarithmic form to exponential form. You can do the same with the natural log form to exponential form. So ln x is the inverse of the natural exponential function. So domain, if you look at f of x equals log x, which is right here, graphed, the domain, which is your input, is anything bigger than 0. You can only put numbers in that are bigger than 0. And the range, your output, is all real numbers. Okay, you can only input things that are bigger than 0, and all real numbers come out. And like we said, all the properties of logarithms from lesson 7.4 apply to natural logarithms. Okay, let's try a few. Simplifying expressions with e or log or ln. So, like we said, when you see ln, if there's nothing written there, it's really base e. So this problem, log, which is base e, that e is not there, of e to 0.15t, just like with the log log, when these two numbers match, your answer is, okay, like this next one. Okay, they're not going to be written in there, but when we have e to the 3 log base e of x plus 1, that's the same as e to the log e x plus 1 to the 3. When these two match, your answer is easy enough. Okay, the same rule applies here. When you're adding, you're really multiplying. So log e to the 2x times e to the x, same base, add your exponents, e to the 3x. Okay, this is really log base e to the 3x, so that equals 3x. So they're all the same rules, you just have to get used to seeing the ln versus the log. Try these on your own, okay? That means you actually try them on your own. There you go. It really is that simple. So you just have to wrap your mind around it. Okay, that's all we have for part 1. Get ready for part 2.